So how can a nanomaterial are used? How can a nanomaterial is used for the remedies of the environmental pollution or environmental contamination? So by pollution or contamination, by collision or contamination, that we generally the substances which are related to the contamination or pollution of environment are generally particulate matters, or heavy metals, pesticide, fertilizers, oil spills, toxic gases, industrial effluents. These are very much now this thing is very much polluting our environment, and the Suez also. The Suez materials also polluting or contaminating our environment. So these are the factors, these are the substances that contaminates or pollutes our environment. You know it better. You had a course, you did a course on environmental chemistry, so you know it. Now, আচ্ছা আমাকে একটা কথা বলো, এটা কি ক্লিয়ারলি দেখা যাচ্ছে?
না স্যার, ঝাপসা আর হচ্ছে মার্ক, ব্ল্যাক মার্ক স্যার।
ব্ল্যাক মার্ক কোন জায়গায়? ব্ল্যাক মার্কটা কোন জায়গায় আসছে? সব জায়গায় নাকি?
না স্যার, এক পাশে শুধু স্যার, ডান পাশে।
ডান পাশে এটা ও এখন ঠিক আছে না?
হ্যাঁ স্যার।
কি হলো আমি তো বুঝতে পারছি না। আমি এটা যদি ফুল স্ক্রিন দেই তাহলে এই অবস্থা হচ্ছে কেন? ওকে, we have different procedures how we can deal with that contaminants. We have different procedures. We know about the different procedures. We read about the different procedures, how we can deal with that this type of contaminants or pollutants. How can we can measure, or we can deal with particulate matters. How we can measure heavy metal, or how we can reduce the heavy metal amount of heavy metal in the environment, or how we can remove the heavy metals from the environment, we know. Now, the use of nanomaterial. Why we use nanomaterial? Why we want to use nanomaterial, or why we will use nanomaterial? Because nanomaterials have some advantages. What are those advantages? You know, high surface to volume ratio. The nanomaterials have high surface to volume ratio. You know it better, as because it is of nano size, so it has a high surface to volume ratio. They can be, that means the nanomaterials can be functionalized or grafted with functional group that can target specific molecules of interest for efficient remediation. What does it mean? A nanomaterial, say for example, a nanomaterial say a gold nanoparticle. A gold nanoparticle can be functionalized, can be worked by grafting, by adding some functional group, by adding some, say for example, this is a gold nanoparticle and I have added OH group here, or COOH group here. I have added another functional group, I can NH2 group here. So uh, uh, the nanomaterial can be functionalized differently by grafting. That means by adding or by incorporating some functional group that can target a specific molecules of interest. Say, for example, an nanomaterial, say for example, a heavy metal. Say, for example, copper. Copper is present in a solution. Now we have to remove the copper from that solution. So I can give a nanomaterial. I can give a I can disperse a nanomaterial in the solution which have a NH2 group grafted with that nanomaterial. Say, for example, I have dispersed some gold nanomaterial which have NH2 group which is grafted to the to that nanomaterial, or I can disperse iron nanomaterial which have NH2 group grafted on that nanomaterial. Then what will happen? This NH2 group will donate electron pair to copper atom and form a coordination compound with copper. Then this iron nanomaterial is attached to your copper by means of NH2 group. The NH2 group, what will do? The NH2 group will donate its lone pair to form a coordination compound with copper. Then this iron nanomaterial is attached with copper. Then what we'll do? If I use a magnet, we can take the iron out as well as the copper also. So I am targeting specific thing. There may be other heavy metals also. There may be other heavy metals also. There may be zinc also. There may be other heavy metals also. But we are specifically targeting copper. How? By adding NH2 group to the iron nanomaterial, by grafting NH2 group to the iron nanomaterial. So, so we can specify a nanomaterial to a particular contaminant or pollutant. So it is said that target specific molecule of interest for efficient remediation, all of the copper atom will go out from the solution. No copper will present. So I can tell that it is entirely copper free. Intentional tuning of physical properties, that means size of nanomaterial. We can increase the size of nanomaterial, or we can decrease the size of nanomaterial. We can increase or decrease or change the morphology of nanosurface. We can add porosity. We can tune the porosity of a nanomaterial, of a nanomaterial. So if we can change this, if we can change the size, we can change the porosity, we can change the morphology of nanomaterial, then we can use it more target specific way. Methods are developed to combine the properties of several different materials. Say silver has a definite property, and some metal semiconductor or metallic semiconductor or a quantum dot has different property. We can add them both together. We can add them both together to get the properties of silver and to get the properties of your metallic semiconductor. Both the properties we can achieve by adding those two those two types of nanomaterials. So we have that methods now. So methods are developed to combine the properties of several different materials. These are the very much advantages for nanomaterials for to use in environmental remediation. But but is nanomaterial itself a contaminant? All the nanomaterials, using the nanomaterials, it is very much risky because it can enter into your body, it can enter into your cell, even it can enter into your cell nucleus because it is not a bulk material. So it can enter to your cell nucleus too. So it may be a contaminant by itself. So you have to use nanomaterial very cautiously. How we can use that nanomaterials? We can use biodegradable nanomaterials, the materials that will degrade it, that will be degraded, even if it enters into my body, it will be degraded. We can use that type of nanomaterial. If we can use the nanomaterial that can be recyclable, we can use the nanomaterial that can be recovered, that means regeneration, that can be recovered. So we cannot use a nanomaterial in the environment as itself. If I use nanomaterial, say for example, in water, and it is not collected, it is not recovered, or it is not degraded, then it will enter into your body and it will do harm inside your body. So, so it is the challenge. It is a very much challenge to develop this type of nanomaterial for environmental remedy. It is a very much challenge for us actually. Now, now where we can use the nanomaterial, you see the water. If I can, okay. Okay, see, this is our main source of pollution or contamination. In water, you have bacteria, pesticides, heavy metals, solvents, oils. In soil, you have food waste, chlorinated compounds that are very much risky for us. You have heavy metals. In air, you have carbon dioxide, ammonia, carboxylic acetaldehyde, NOx, SOx, etc. Now, we can remove the contaminants or pollutants by means of filtration, by filter or different types of membranes, by use of sorbents. Sorbents means adsorbents that can adsorb the contaminated material, or that can adsorb the contaminating material that are contaminating. So these are called sorbents. As for example, sponges that can absorb the contaminated contaminants. Uh, this is absorption. Absorption means it can be done by nanotube or by any nanoparticles. It can be decomposed by means of photocatalyst, by means of UV light or something, and it can be reduced to different substances, or it can be oxidized to different substances by means of nanoparticle. So there are various methods by which a nanoparticle, there are various methods by which a nanoparticle, a nanoparticle actually can be used to for the remedy of the of your contaminated substance, or of your polluted substance. That means for the remedy of environment. Now, there are, but these are not used very frequently. The nanoparticles are not used very frequently. Why? Because they are now in the experimental stage. They are not used very frequently. You will not get a substance or get a machine that can use nanoparticle and that can clean the environment. You will not get very often this type of machine, because all are everything now. You see absorption of nanoparticle or photocatalysis by nanoparticle or sorbents. Everything is in now in research stage. So it will take some time. It will take some time, because the nanomaterial itself a pollutant or contaminant. I told you the nanomaterial itself a pollutant or contaminant. So, we have to see that we are using nanomaterial or we are using nanoparticle, whether it is it can remove the pollutant or contaminant from the environment, but the nanomaterial itself is safe for us. So we have to see this for a definite time period, actually, for a definite time period. Hence, for that, it is not used very frequently. If you have a ETP, say for example, an industry must have an ETP at effluent treatment plant. If you can use nanoparticle in the ETP, then it will the efficiency of that ETP will be higher. Why? Because if you are using nanoparticle, the cost of nanoparticle is very low, because a small amount of substance you are requiring. So the ETP cost by itself will come down. But still we don't know this nanoparticle will be harmful or not. So it is not used very frequently. It is used for in some fields, but not widely used. So it is still in research stage, advanced research stage, I can say. After doing some research, after some time, after examining this some time, we can use these nanomaterials or nanoparticles to different fields to remove the pollutants and contaminants from the environment. Now, that's all for today. We'll see you tomorrow. আজকের জন্য এখানে থাক।